Good morning, students. Hope you all are fine and safe in your homes. Due to the pandemic situation, we have to do the classes in online, right? Are you enjoying the online classes? Yes. Okay, very good. Today, we are dealing with many of subjects. Yes. Are you interested to learn science, especially the chemistry subject? Yes, very good. Today we are going to study chemistry. Uh, are you ready to learn chemistry? Yes, very good. Oh, then you are ready. I am also ready for tutoring chemistry. Let us begin our today's class. In earlier class, we learned about the chemical changes chapter and we learned some of the portions from the chapter. But we learned in the yesterday's class. What are the topics we dealt in the yesterday's class? Yes, they are chemical changes and physical changes. What are the difference between the chemical change and physical change? Then we deal with the different types of chemical reaction, right? They are photochemical reaction and thermochemical reaction. And in that class we'll say that there are so many other type of chemical reactions. So today we are going to deal with another chemical reaction and that is electrochemical reaction. Yes, today we are going to study about electrochemical reactions. What is electrochemical reaction? Do you know about some electrochemical reactions? Yes, it's a chemical reaction. Very good. And some more about it. It's related to electricity. Very good. It is electrochemical combinated reactions. There are electricity and also chemical reactions happening in that reaction. So this is a electrochemical reaction. Let us do an experiment together, okay? First we draw the apparatus for that experimental setup. Okay, take a beaker. Fill 3/4 of the beaker with diluted copper sulfate solution and put 2 electrodes. They are carbon rods and connected by a battery with a switch. Okay. When we passes electricity, that is when the battery switch is on, what we have to observe the changes happening to this solution. Okay, what are the changes we can observe from this experiment after passing electricity? We have to observe that. And you have to write your observations in your activity card. Okay, when the electricity is passed or when the switch is on, the copper from the diluted copper sulfate solution is deposited into one of the carbon rods. We can observe the changes is the color of the copper sulfate solution is reduced and the copper from the copper sulfate solution, is deposited into one of the electrode. Okay, do you understand? Okay, can anyone read the questions in activity card? What is the first question? Yes, very good. What happens to the color of the copper sulfate solution. What happens to the color of copper sulfate solution? Anybody can answer to that question? Yes, what happens? The color of copper sulfate solution is reduced. It becomes dim. And what happens to the carbon rods or electrodes? Yes, very good. The copper from the copper sulfate solution is deposited into one of the electrode. Okay, students. From this experiment, we can we can see that the color of the copper sulfate solution become dim and it is deposited into carbon rods. So it proves that a chemical change has occurred in this reaction. And firstly, we on the switch of we provide an electricity to that, and from this we can see that a chemical changes happen to this reaction experiment. So this is an electrochemical reaction. Okay, students, which form of energy is responsible for this chemical change? Can anyone say? Yes, very good. It's electrical energy. Okay, very good. Okay, in this reaction, copper sulfate decomposed with the absorption of what? Electrical energy. Okay, the process in which a substance undergoes, okay, once more, the process in which the substance undergoes by the decomposition and absorption of electrical energy is known as electrolysis. What is electrolysis? The process in which a substance undergoes decomposition by absorption of its electrical energy is known as electrolysis. Okay, this is an electrolysis. This is an example for electrolysis. This solution is known as, the given solution is known as electrolyte. What are the solution known as? Electrolyte. Which are the common electrolytes used for electrolysis? Sodium chloride, copper sulfate, silver nitrate. Sodium chloride, copper sulfate, silver nitrate, AgNO3. Okay, these are the common electrolytes used for our electrolysis reactions. And the carbon rods are known as electrodes. Okay, three words: electrodes, electrolysis and electrolyte. What is electrolysis? The process in which a substance undergoes decomposition by the absorption of electrical energy is known as electrolysis. And what are electrolytes? Electrolytes are the substances used as a solution. Which are the common electrolytes used in electrolysis? Sodium chloride, yes, copper sulfate and AgNO3, silver nitrates. And what are the electrodes? They are the rods which connected to the poles of battery which transfer electricity to the electrolyte are known as electrodes. Okay. Okay, we watched electrochemical reaction, and now we are going to do an experiment to prove the electrochemical reaction. All of you are familiar with lemons, right? Which is the acid present in lemon? Yes, very good. It's citric acid. In all of the almost all fruits contain acids in it. Lemon contains citric acid in it. Okay, take a few lemons and it's fixed with a copper rod and a zinc strip. Okay, let us see the video of this experiment and observe it carefully and answer the questions given to the activity card.
When life gives you lemons, make a lemon battery. You just need a few copper pennies, some wire, galvanized nails, those lemons life gave you, and science. This episode is a hands-on activity where we build a lemon battery to power an LED, whereas the follow-up episode goes under the rind to explore the physics and underpinning science around how all this works. These episodes will help provide an in-depth understanding of electricity. Let's switch out of animation and get started building the battery. For this activity, you'll need these materials. You'll also need these tools. A step-by-step procedure is linked in the description. If you're under 12, ask an adult before starting this activity. Also, a few tips for safety. Don't eat or drink any of the lemons or objects that we use. This is because the metal in the nails leaches into the lemons, and eating that isn't good for you, so just don't. And be careful with the nails, wire, and wire cutters. Don't hurt yourself. So, now let's build this lemon battery and start generating electricity. First, take a lemon and press and roll it on the counter to break up some of the internal structures in the lemon and release the juices. Second, push 4 nails into one side of the lemon. The nails should be as close as possible and touching one another. Third, cut a good length of wire about yay long and use it to make a small row of punctures on the other side of the lemon, away from the nails. Now push a penny into the lemon where you made the row of punctures. Then press a second and then a third penny into the lemon. Fourth, take the copper wire and loosely coil it around your finger a few times. Flatten the coil and press it into the lemon between 2 of the pennies. To make sure there's enough copper surface area, push in a few more pennies. This is science, but not exact science, so have fun with it. You may want to add a second shorter coil of wire into the lemon and attach it to the first like I've done here. The goal is to have a lot of copper surface area in the lemon with a good connection from the pennies to the wire. Also, make sure that the copper pennies don't touch any of the nails inside the lemon. If they were to, the battery wouldn't work. And that's it, you built a lemon battery. Now let's try and light up this LED. And it doesn't work. And that's because one of these lemon batteries doesn't provide enough voltage to light the LED, and therefore we have to use 3 of these batteries in series to make a super lemon battery. So fifth, let's build 2 more lemon batteries identical to the first. In order to combine the power from 3 batteries to make a super lemon battery, we are going to place them in series. To do this, we'll use some tape and a marker to label the lemons number 1, 2, and 3. Now take the copper wire from lemon number 1 and use the pliers to wrap it tightly around the nails on lemon number 2, and then do the same with the copper wire from lemon number 2 by wrapping it around the nails on lemon number 3. Next, cut an additional length of copper wire and wrap it around the nails on number 1, and then tape and label this wire negative. Then, tape and label the copper wire out of number 3 as positive. To light the LED, take the negative wire and press it to the shorter leg on the LED, and take the positive wire and press it to the longer leg. It works! You just generated electricity using some lemons, nails, wire, and copper pennies, and then used that electricity to power an LED and produce light. Good job! Our super lemon battery is done. Here are some questions for you to think about. Consider them, and we'll explain the answers and more in the next episode, so stick around for that. Also, if you had issues with your lemon battery, read the description to troubleshoot. Probably the answer will be in there. Thanks for watching. Don't forget to like, subscribe, and share with others. If you have any questions or ideas, post them in the comments below. This episode branches to exploring lemon batteries, voltage and current, lithium-ion batteries, and understanding electricity. Also, remember to think about the conceptual simplicity and structural complexity throughout the world around you.
Okay students, hope all of you understand the today's class. What we learned in today's class? What are the topics we are dealing in the today's class? These are electrochemical reactions. Very good. What is an electrochemical reaction? Can anyone conclude what is electrochemical reaction? Yes, very good. It's a combination of electrical and chemical reactions. Okay, what is electrochemical reactions? They are chemical reactions in which electricity is consumed or produced is known as electrochemical reactions. Okay, once more, what is electrochemical reactions? The chemical reactions in which electricity is produced or consumed is known as electrochemical reactions. Okay students, I think all of you understood this today's class.